This is a video on alternating series. The question states, determine if the following series converges conditionally, absolutely, or diverges. We have the summation from n equals 2 to infinity of negative 1 to the n over n minus 1 quantity squared. So because of this negative 1 to the n, we have an alternating series. So we want to see if it's conditionally convergent, absolutely, or if it diverges. So notice that as n gets large, these terms go to 0. So I'm not guessing that this diverges. Usually when an alternating series diverges, the limit doesn't go to 0. So let's see if we can guess if it's conditionally or absolutely convergent. Well, if we kind of get rid of the negative 1 to the n, in other words, we take the absolute value, then we get 1 over n minus 1 squared. That kind of looks like the p-series 1 over n squared. So our strategy is to show that this is an absolutely convergent series because it looks kind of like the convergent p-series. So I'm going to use the limit comparison test, and I'm going to compare with the summation of 1 over n squared. So I take the limit as n approaches infinity of 1 over n minus 1 squared divided by 1 over n squared. And that's the same as multiplying by the reciprocal. And then I can use the algebra trick that says if we have the same power on top and bottom, we can combine this as a fraction to that power. Or in other words, we get the limit as n goes to infinity of n over n minus 1 quantity squared. When we have limits of a square, that's the same thing as the square of the limit. So I can pull the 2 outside and write this as the limit as n goes to infinity of n over n minus 1 all quantity squared. So taking this limit, if I plug in, I get infinity divided by infinity quantity squared. And when we have infinity over infinity, I can invoke L'Hopital's rule. So the derivative of n is 1, and the derivative of n minus 1 is also 1. So I get the limit as n goes to infinity of 1 over 1 all squared. And that just reduces to 1. And that's good because I'm using the limit comparison test. So I'm looking for a number that's not 0 and doesn't go to infinity. And 1 is certainly not 0 or infinity. So the limit comparison test tells us that the series, the summation of 1 over n minus 1 squared, does the same thing in terms of convergence or divergence as the series 1 over n squared. And the series, the summation of 1 over n squared, converges, as we mentioned before, by the p-series test. P is 2. So the limit comparison test tells us that the series summation n equals 2 to infinity of 1 over n minus 1 squared, that was the absolute value terms, also converges. So now we're ready for our conclusion. Since the absolute value terms converge, we can conclude that the summation of n equals 2 to infinity of negative 1 to the n over n minus 1 squared converges absolutely. And I'm done with the problem.